Okay, so I'm back, and I decided to dive in a little bit more. I found out that I had a couple of errors. So a couple of these functions, or basically I had some things screwed up in here. And I finally got it to where I think I got it correct. A couple of things to note here. The get square root really matters in terms of getting precision. Just by changing this from an 8 to a 9 seems to help. And of course, the more iterations you do will help. So there's kind of a balance, and the balance that I'm fighting is somebody where I work mentioned this site, Big Number Calculator. Okay, so you can put in these numbers and do x divided by y and tell it to calculate it for you. Would be nice if this thing did it, but you know, whatever. It seems like actually, yeah, that's an odd number, so that's an even number because it's all a bunch of zeros at the end. As you can see here, 3.1418, you know. But the problem is that if I just increase it by, like, say, make this 6 and run it, I think what I get is to a point where when I put in one of these numbers, oh, that didn't. Okay, so that's good. Put in, yeah, that's fine. So it's really didn't matter that much. So yeah, it seems like it's getting closer-ish, but like let me back it up. If I do like just 2 iterations, and I do that, put it in there, take this, put it in there. Yeah, it gets a little like the decimals over here. But if I, was it just 2? But I make this 10, let's see what that does. Now we get a number that I just can't put in because it's just too big, and it won't take that into the thing. But if I do something like just make this 4 and crank this up to like 25, and I run this, well, I get numbers that are smaller, but watch what happens. So I'll put that in there, like that, put that in there. And you see we're 19. It's just not enough. So it's like I'm fighting this little battle here. If I jump this up to, let's say, 6 and run it, where are we? We're at like 19.8. Now we're down to 5. So just that seems to help in terms of getting close to that. So what I would really need is something that would, you know, do the thing with the stuff. And I can't just crank this up to like 75 and hope to get really good precision that way, because then again I get a number that if I try to put this in here and I do that, 37, it's too big. It won't fit in here. What I really need to do is find a site that lets me put in god-awful huge integer for the x and a god-awful huge integer for the y, and then let me calculate it. And it just doesn't seem to let you, this site just doesn't seem to let you do it. I tried Wolfram, that didn't do it. It's just, you know, there's nothing that. It looks like they're actually putting the cx and the cy up here. Let me actually look at this. What are they doing here? So it's CX, CY, CP, and CO. So I could say CX, CY, and then CP. CPU is a precision. And what was the other one? And the operations. So if I did, what do I got this set to? 6. Well, let's just see what this X. I'll come back over here. I don't know if it's going to allow me to push so much onto the query string, so it might just die on the vine this way. So we're going to take all of that. I'm going to say Cx is equal to that. I'm going to say Cy, nope, is equal to that. Can't get my hand. Why am I keep doing the same stupidness? Okay. Grab all that. Come back up here. Why are you doing Facebook, you stupid? Yeah, it's not. It won't do it. It's just not big enough in the query string. What I really want to do is a post to the site, and then let me put in any arbitrary size and whatever. So I think this is right, and I might just publish this to my GitHub site. Why not? And make some notes around it and see what people can come up with. But it does seem correctish. If I make this square root, at least like an 8, and I start to do more iterations, it seems like you're getting to where it gets closer and closer, but without being able to calculate bigger numbers, I can't tell. So the one thing I do want to state is the reason why this caught my attention, and I may have mentioned this before, is when I was in college, I did let me see if this is actually going to get the glare. So that's my master's thesis. So, and I had to calculate pi as my test. So way back here, you can see in the appendix, try to get the glare off there a little bit. There we go. So you can see those numbers of pi, right? Ooh, pi. So this has just always been something that's kind of an interesting thing to me. I'm thinking of actually doing a talk, at least at the next Twin Cities Code Camp, and doing just a fun talk on big numbers, and one of them being this, because I don't know why. I just have always had an interest in really large numbers. So if I can find a site somewhere that'll let you put in arbitrary numbers, then I will see if this, because what I could do with this then is then post as I'm like getting different values out of pi when I say 70, like 16, 75, 100, 200, 400. What it would really be nice is if this big rational was set up to be reducible, like it was like this. If it knew it was 3 to the 6, 3 6, then it really goes to 1/2. But reduction algorithm. So yeah, I thought it had something in here where I was talking about that it used that. Power fraction part. Compare to string. Equals. I don't think. Yeah, I noticed it had a pow in here, so that was good. It does have an LCD, but oh, it does have a, oh, simplify. Why not? Okay, the last thing, and then I'm going to start recording. See, this is the danger. Simple pi, singular pi, dot simplify. Now, of course, I have no idea if this is actually going to, yeah, you don't assign it. It's mutable, which is probably not the greatest design. I don't know if that would stick anymore. But let's see what we can see. So I don't even know if that helped. Let's like do 20. It does. It definitely looks like it does. It does make them look smaller. And then what am I doing down here? 6. Let's bump that up to an 8. Let's just take this. See if that can fit in there. 6, 9. It does. .17. Okay. Let's go to 30. I'm going to take this. 83. It does. So we're at 17. Yep, still not. Doesn't make a difference after. That's kind of interesting that after a certain point it just didn't seem to matter. One last thing. Just a 9. That's going to be too big. Well, let's go back down to 20 here. That's probably too big. 83. Yeah, too big, so I won't take it. All right, so the simplified does seem to help, though. Or does it? Did it? 3, 8? Well, no, not in this case it doesn't, because there's just no way to simplify it. 1, 9. Yeah, it's not simplifying it any more than it can. But I mean, in some cases it definitely was, I think. Or was I just deceiving myself? I think I might have been deceiving myself. Yeah, I might have been. I don't know. The interesting thing, though, out of all this is that it's interesting because that paper I just showed you and the amount of work that it took for me to put this all together, you know, and the algorithm, you know, the code. I'm not going to switch back and see if you can see that or not, but it is awful C code. It is just horrible, and you know, but it worked. It took. I've got all my notes still up there. I think I've said before I might publish it at some point, but yeah, it just. It took a lot of time to figure it out. I'm going to do one more thing here. Let's say console right line. First we're going to go say var x is equal to new big rational of, let's say 50, 10. Okay. Then we're going to say x simplify. So I'm going to say print out x. 5/1. So it's actually, it's doing the right thing. It is simplifying. It's just when you get to those numbers, it's not big. Okay, so I think I might end up actually putting this out on GitHub and just having fun with it and seeing if somebody can, to do that is to see if there's a way as these numbers get bigger and bigger to just arbitrarily post somewhere to see could you do these thousands of numbers divide by 2 or divide. And again, as I mentioned with this, the fact that you can do something where it's like that much code and boom, you have pi. Now, of course, I'm using supporting libraries here to handle some of these really big number type of things where you didn't have that before. And I can't, again, use big integer here. I have to use big rational because of the divides. If that wasn't there, then maybe, but at some point, that's just not going to work. So yeah, it's interesting. It's kind of a fun little exercise. Actually, God, how long have I been recording now? 16. Oh, so, what I could do is after every one of these, say simplify. L, that's simplify. X, that's simplify. S, simplify. K, simplify. So I don't know if that really even helped, because this, I don't think I can, what was it, 63? It does. I don't know if this is really going to, 1418. Well, cool, because if I take these out, and run it, I think that's the same one. So did it help at all? Nope, it didn't. It didn't. I was hoping it would, but it doesn't seem to really help that much. It's kind of, I just can't stop myself, can I? I just have to watch these things. You don't. I just saw an article about how to make your values look sane. You know what I mean? That's interesting. What is this? Yeah, S is the one that gets to be a pain. Yep. S is the one that gets to be a pain. I say s.simplify. Yeah, it doesn't matter. It's it can't simplify it. So yeah, because I think all the rest of these, if I'm looking at these, they always stay to be. Even M is kind of weird because you'd think as you're doing this that you would get some I'm sorry, not KM. You think you would be getting something from the divide. And you're not. You're staying there. The whole thing stays there. That's bizarre. So is it like the only thing that matters is the S? In terms of precision, in terms of having to have, am I passing in here 5? So just kind of another interesting observation that you never seem because M and K are the only things. MK and K just keeps getting 12 added to it. And this just keeps getting 1 added to it. And M is just that. Yeah, kind of interesting. Anyway, fun little endeavor. This may keep tugging at my head to go how to do this, but again, it seems like it gets closer if I could just ramp up the precision and then figure out how close I'm getting. With just a simple algorithm, you can get a result really, really fast. So anyway, I'm going to stop because this has probably made my episode the longest one ever that I made, but it's been fun. So anyway, I'm going to stop for now. So we'll see you next time. I might do some rock stuff, I think. So that's all for now. Leave comments and questions below. See you in the next episode.